Okay, I'm going to hide this, so pretend you couldn't see the answers. A bit late now, but pretend you couldn't. Here we go. Last time we looked at standard integrals. Today we're just going to get more and more practice at finding areas under the curves using the fundamental theorem, which basically says this. If you want to find the integral, the area under a curve, the integral from AB of some function f of x dx, then you evaluate the antiderivative at B, and then you evaluate the antiderivative of A, and you subtract them. And it's such a lovely, simple package, right? As long as you know how to find antiderivatives, which is typically what you'd expect. So you're not allowed to cheat here, which means you're not allowed to look at Friday's notes. You're going to have to do it from memory. So here it goes. Antiderivative of e to the x. Just share it out, anybody.
E to the x?
Agreed. Antiderivative of sine x. Be careful.
Cosine x?
Be careful.
Negative cosine x.
Great. Antiderivative. Derivative is cosine, but antiderivative is negative, right? That's a common mistake. So you're not the only one to make that mistake. Probably me sometime as well. Oh, darn it, I've just told you that one. Okay. Secant squared.
Tangent squared x?
Take out the square, but tangent. Tangent x. 1 over 1 plus x squared.
Natural log.
Arctan?
I hear natural log. I like it. You're right. Oops. Well, I'll show you now. 1 over 1 minus x squared. Inverse sign. One over x. You'll have to hit the spacebar. Well, I'm assuming you will. 1 over x.
Natural log of x.
Correct. If the book's being awkward, what will you sometimes write instead of the natural log of x?
Absolute value of the natural log.
Right. Well, not the absolute value, but the log of the absolute value. If you put the absolute value in the wrong place, it'll probably tell you you're wrong as well. So if you do an answer and it ends up being the natural log of 2x plus 1 or something, right? Just random. If it doesn't like it, call it the natural log of the absolute value of 2x plus 1, and it probably will like it. Sometimes it needs the absolute value, sometimes it doesn't. I'm not quite sure how it decided. And I told you, I'm sure I told you last time, I basically don't worry too much about that. We'll just assume that you'll never use the answer in a place where it would be silly, right? Secant tan. Don't know if we did that last time. Secant tan.
Secant?
Well done. Yes. So it's good, just good practice, good skill building to just memorize these bloody things. It's something you got to do. If you have to keep looking up bits of paper to find antiderivatives of things, it's going to break your thought process and it's just going to slow you down. So this isn't all the antiderivatives in the universe. There are tons of them. But these are pretty much the bread and butter ones, right? The ones you're going to see a lot of. And so these ones I would certainly get into my, my little file of facts. Now, there's others that are not in this list. For instance, I haven't put down what cosecant squared x is. And in that case, you might have to go and look it up. Anybody want to have a guess at what cosecant squared x antiderivative is? It's negative cotangent x, for instance. So if you come across something that's not on the list, which I suspect you're only going to do rarely, but if you do, you know that you can find it, can't you? You can go online and say, what's the antiderivative of cosecant squared x? Or you could look at your ebook, because very often in the ebook, they've got a little table with all the basic ones and some extras. So what's today's job going to be about? We are going to get good because we're going to do lots of practice. at finding these guys. So let's start with what I don't think is a major issue, but it causes problems for some people. Let's look at using the power rule. I'm thinking about it. I'll keep this guy handy. Use the power rule for polynomials. Well, first thing you do is find the antiderivative. In this case, add 1 to the power and divide by the new power. So that was a nice easy one, right? The antiderivative of 3x squared is x cubed. Now it gets a bit messy. What's the antiderivative of this guy? Well, you add 1 to its power. Now, if you divide a half by 3, it's 1/6. Agreed? 1/6. Now, add 1 to the power, divide by the new power. There we go. 3/8. And what do we do about 1? The antiderivative of the number 1.
It's just x.
Just x. And isn't 7 just 7x? And minus a half is just minus a half x. And we evaluate this at 0 and at 1. That's the usual notation. So 1 cubed, 1/6 of 1, 3/8 of 1, and 1. Take away a big load of zeros. When you're doing your working for questions like this, occasionally you can cut out a whole load of extra writing. Would you agree that it doesn't matter what number I put in here, any power of 1 is 1. So I basically just need to use those. Agreed? Now, why can I just plug in 0 instead of writing down 0 cubed plus a 6, 0, and all the other stuff? Aren't they basically all zeros? So, you know, if you can see some shortcuts, the most likely places you're going to get shortcuts from is when you use x equals 1 and x equals 0, right? Those two numbers tend to generate a lot of answers which are just nice to do. Now, we are left with this calculation. So I'm going to go and do 1, add 1/6, take away 3/8, add 1 again. And that's what the answer looks like as a decimal. Am I going to write that down in the homework? Nope. Aren't we going to do math button convert me to a fraction and write down 43/24? We consider the best form for these types of answers to be what you call an improper fraction, right? A fraction like 47/9 and 33/25 and things like that, right? That's how they should be read. It won't like it as a decimal, and it won't like it if you write 1 and 13/24 or 23/24, I think, or whatever it might be. It won't like mixed fractions. Well, share a little thing with you. That's an example of an improper fraction, isn't it? What you call an improper fraction. If I write it like this, I think you would call it a mixed fraction. Is that the names you're used to? Improper fraction, mixed fraction.
Mixed number.
Mixed number. Do you ever call it mixed fraction or just mixed number? Mixed number?
I just
Okay.
remember mixed.
That'll work. Back home, Scotland, which is probably why I called it that. We call this a mixed fraction, which is not a biggie deal because you might call it that yourself. But we have a much better name in Scotland for that guy. I don't like, I'm getting little beeps. I think it's going weird on me again. I'm just going to ignore them. We call that an improper fraction in America, don't you? I don't think you have another name for it. And I said, we have a much better name for it in Scotland. We call it a top-heavy fraction. I like names to help you understand what it is. I don't, maybe it's just my brain, but doesn't top-heavy fraction make you think of fractions where the top heavy is big? And that would have been such a, in my opinion, such a nicer name for those fractions. Because when you say improper fraction, doesn't it sound like it's wrong? You shouldn't be doing it that way, when actually we want you to do it that way. Right, I'm going to find out why this thing is dinging at me, because if it's dinging at me for a reason that I should be worried about. No. Can you hear that ding, or is it just me?
It's just you.
Okay, so it means it's my computer is dinging at me. It's going like ding. It's annoying, but okay. Since today has been full of lots of little annoyances, I guess I'll just add that to the list. Okay, so first job. Are we comfortable with antiderivatives of polynomials? How about an antiderivative of this guy?
We can't see your screen.
Oh, thank you for telling me that. How about an antiderivative of this guy? You won't find any square roots over here. There is not a square root of x antiderivative here, right? And it doesn't need to be here, because this guy in about the next 3 or 4 questions, they're all going to be the power rule. They might not look it, but they're all going to end up being the power rule. What we have to do is to write it in a form that allows us to do the power rule. Do not think of the power rule saying, oh, it's only usable for 5x cubed or 4x squared, right? Power rule can be used for any power of x, even fractional powers or negative powers. So if I rewrite this guy as the integral from 0 to 4 of 4x to the half, would you agree that's the same thing mathematically? Fractional powers, half, is the same as square roots. Now, according to the power rule, if you say it in English, don't you add 1 to the power? If you notice, add 1 to half. We don't write x to the power of 1.5, don't we? Write it as a top-heavy fraction, 3/2. In fact, I think I'm going to start using top-heavy fraction and forget what Americans call it, right? Top-heavy fraction, right? 3/2. Or what do you do with the new power? You add 1 to the power and then you do something with it.
Divide by it.
Right. How do you divide by 3/2? What's another way of dividing by 3/2?
Multiplying by
Right. By 2/3. So are you comfortable where 8/3 came from? This is the antiderivative of that. Can't you check it by just differentiation? So it works. It's going to be evaluated at x equals 0 and x equals 4. So here's the next problem. I know what I'm going to do. There. Okay. 3/2, way back in Math 99. Do you remember fractional powers can be written as radicals? Now you might say, well, why do I need to do that? Remember, we want to get the exact value when we're finished. The exact value isn't 5 to the power of 3/4 or 2 to the power of a half or things like that. Shouldn't the exact value be square roots and cube roots, because the original question was in that format? So returning the guy back to the original, right? The way the question was written is going to be helpful. So here goes. It's going to be 8/3 the square root of 4 cubed. Take away 8/3 that guy. I probably shouldn't have written that guy because I know what he is. What's that guy going to be equal to?
0.
0. Can you tell that before I even wrote it was going to be 0? So if I wanted to make my life easier, don't write this down. I should have probably written this guy as that. Shouldn't I? Take away 0 doesn't count. Right, now, 4 cubed is 64. And the 64 gets you 8, and 8 eighths gets me 64. Hopefully I did that all correct. It's 64 thirds. Agreed? Can we pretend that that number wasn't 4? Can we pretend that number was, say, 5? Right, a different question. This would become 8 thirds of 5 cubed, which would have been 8 thirds the square root of 125, which you might be quite happy with. But shouldn't you always simplify as much as possible any answer? Now, that could be as simple as 4 eighths become a half. But do you know that you can simplify this radical, this root? Agreed? Does anybody know what it becomes before I maybe do it?
5 root 5.
5 root 5. It's 25 times 5, it's 5 root 5. So you now have 8 thirds 5 root 5, that 8 gets you that guy. And that would be your final answer. And this would be your final answer here. Now, can you use this technique for cube roots? I won't do the question, just the start of it. If somebody said to you, I want you to find this fella, what should I turn? What fractional power should the cube root be?
1/3.
1/3. Let's make it harder. What fractional power should the cube root of x squared be then?
2/3.
2/3. Can you remember doing in Math 99, if you did Math 99 here, or at least you did it in your high school, can you remember the sections dealing with fractional powers and indices, and how square roots and cube roots can be turned into fractional powers and fractional powers can be turned into radicals? Isn't that what we're doing here? What you got to realize that although you may be in Calc 2, that does not mean that all the stuff that you did from 94 and 99 and 141 and 142 that you can forget about because you've done that and it's never going to happen again. That's not the way math works. If you got rusty in this, can you see if you weren't able to do this, you'd have problems doing this question. You're then going to have to deal with fractions. Now, if you add 1 to this, don't you get 5/3? And then shouldn't you then divide by 5/3, which basically means multiply by 3/5, and that's where that guy comes from. And then to make sure that you at least have a fighting chance of getting an answer, and I strongly suspect that that's an ugly, ugly, ugly answer, but it does have a value. And that's where you would go to. So we know how to deal with polynomials. We now know how to deal with square roots. How about this guy? And you might be saying, oh, wait a minute, it's not x's anymore. You've changed the variable and you've called it u. Do you know mathematically, these two questions are identical? Isn't the choice of variable really just a choice? I want to call it x because it's whatever it is. Right, maybe the next time the variable u makes more sense because it's something to do, you know, maybe it's d the next time where d is distance, right? Or v the next time and v is velocity, right? You're in physics, you use variables with different letters. It's good practice just to not get too comfortable that everything's an x, right? It makes no difference. But there is another problem, and that is, that's no good. The way that's written is no use to me because I won't be able to use the power rule, because that's what it's going to be. What do I have to do?
Foil.
Okay, now if we foil it, I hope I do it right. You get that. And then add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power, and call the 6 6u, and evaluate it at u equals 1 and u equals 2. And now I'm going to do my dreaded ... Normally when I put ... all I'm saying is, you know, you could finish that yourself, isn't it? Just a matter of plugging in some numbers and getting the answer 42. And so I'm not going to finish it. That seemed reasonable. If nobody told you, I hope that's probably how you would have approached that. Let's change. How about this guy? Would you agree that I can't do anything in this format? I have to change it into something that allows me again to do the power rule. What would this become?
Write it twice and then foil it.
Right, so you basically, you multiply it by itself twice. So sounds like what you're saying, agree? Isn't this just a foil? So you're going to get 4x squared. You're going to get plus 12x and plus 9. Let me tell you about a mistake. People go from here to here, but that's not what they write. Have you ever done the I forgot the middle term mistake? I make mistakes everywhere, so I bet you have done it. You recognize that there is a third term, right? It's not 2x times itself, which is 4x squared, and only 3 times itself is 9. Isn't there a 2 times 3 and a 3 times 2x, which add up to 12x in the middle? So be careful if you do that mistake. Add 1 to the power and divide by the new power. Add 1 to the power, divide by the new power, and the 9 is called 9x. And ... again, right? I don't see any reason for... Any questions so far? Have you noticed that we haven't left power series yet, right? I haven't used the power rule yet. Everything's eventually became a power rule. Still in the power rule world. And I'll give you a big hint here. I'm saying, look, we're still in the power rule world. So somehow or other, I'm going to have to be able to use the power rule on that. This is from Math 99. Can't you write that as a negative power of x? And it's that guy. Agreed? Now, the power rule honestly doesn't care. That power can be a fraction, that power can be a number, that power can be negative, that power can be anything you like, except -1, but anything else, and that will work. So now we have to be careful about what the power rule says. The power rule says, add 1 to the power. What is the new power? Be very careful. I'm giving you a warning. Add
Negative.
1 to that power. What is the new power?
-2.
Correct. Do you know what a common mistake is? -4.
Subtract 1 instead of adding 1.
Yeah. Well, yeah, you're adding 1 to the 3, but you're not really adding 1, you know, because -3 plus 1 is -2. So be careful with that. It's such an easy mistake to make. Now, if you divide by the new power, you'll get that guy. And we're going to evaluate them at 1 and 2. But since I need exact values, that's not a good format. So remember my rule about returning to the original? This becomes the same as that. So do you see I'm using x's on the bottom become negative powers, and then later on I'm using negative powers become x's on the bottom. But this format is much nicer because plug in 2 and then plug in 1. And this guy gets me -1/4. And this guy gets me 2 negatives, so it's a +2. So I believe eventually the answer is +7/4. Got a nod, so I must have
Is
done
it
it right.
-2 over 2 squared?
No,
1/2.
it's 1 squared.
No, the first one. The
Uh-huh.
-2 over 2 squared. Isn't that 1/2?
Whoa. Darn it in space. You notice I don't swear. Am I really good at not swearing? I'm not going to quote any person's name, but I have been told by other students that there are some professors who swear when something like that happens. And see, I'm taking a lot of kudos for having great self-control. But thank you for catching that. 3/2. So do you see that we can do 5 over x squared, 20 over x to the 10? How about this fella? It's a bit of, it's not really fish, it's not really foul, right? It's got a square root in it, but it's got a fraction in it. I mean, where is it? Well, this is where it is. What power of x will a 1 over square root of x get you?
-1/2.
Now, the minute you do that, would you agree this is now a power rule? There's kind of theme for the last 20 minutes, hasn't it been the guy I've got I can't use, but if I can turn them into powers of x, I can use a power rule. That's kind of been the theme. So add 1 to the power. Oh, what do you get if you divide, or what's another way of calculating divide by 1/2?
Multiply by 2.
And that's where the 16 came from. You comfortable with that? You know I'm not going to leave it like that. Would you agree I'm going to turn it into the square root of x? I'm trying to be consistent here. Do you see I always return back to the format of the original? Now, in this particular case, 16 square root of 4, take away 16 square root of 1. I believe the answer is 16. Well, you all know I can't count, especially when I go fast, but this time I got it right. Okay. Now, I'm not going to do this question to the end because we've got so many permutations I want to do. Let's just talk about what that would be converted to and what the antiderivative would be, and then I'll stop. What would this become as a fractional power of x?
-2/3.
-2/3.
Agreed. -2/3. In this case, then, wouldn't you add 1 to the power? So negative 2/3 add 1 is positive 1/3. And then divide by 1/3 is the same as multiplying by 3, so that's why you got a 30 there. And then you do x equals 1 to x equals 4. I guess I could take it one last step. But at this point here, can't we just, plug in some numbers and make it look pretty? And it's okay for your answer to be things like 30 cube root of 4, take away 30, or 20 cube root of 17, take away 40 cube root of 3 or something, right? Very often exact values are pretty ugly, right? They don't have a very clean look to them. And the book's fine with that. Are we good? Right. What else have I got? I think. Oh, there are just so many polynomials in the world. Still the power rule. Suggestions how to what to do next, how to fix this?
Distribute the square root of x.
Would you leave it as a square root of x right now, or would you do something to it first and then distribute it?
Make it x to the 1/2 first.
I agree. And as you distribute it, don't you basically just add the power to the one that's there? So it's going to be, x to the 2.5, which is the top heavy fraction 5/2, take away x to the 3/2. So this guy became that guy. Now in this format, would you agree that this is doable, right? The power rule will work. It'll be pretty messy fractions, I'm guaranteeing that. If you add 1 to the power, you get 7/2, and then divide by that, you get 2/7. If you add 1 to this, you get 5/2. If you divide by 5/2, which is the same as multiplying, you get this guy. You then should convert and at this point I'm dotting it, but can you imagine you could get an answer? Plug in 2, then plug in 1, little bracket. We are good. Do you see how much different versions there are of just the power rule? Right, we've not even left the power rule. Right, we're still doing different algebraic ways of using it to get antiderivatives and definite integrals. This is at least the last one I can think of that still is a power rule. There's a teaser for you. That's going to be a power rule eventually. But we got to get there, right? And that's where the algebra takes over. Any suggestions for what the next line could look like?
Multiply that top term by v to the negative 3rd, and then distribute in the next step.
And what you said is correct in every way. But I guess it's my British ears. I don't like this being called negative 1/3. Because 1/3 makes me think 1/3. So I would just call it v to the power of -3, but I know exactly what you meant. So you were correct. I'm just being nitpicky. Now, what do you get when you multiply? Let's change colors. This guy, because I'm going to distribute this guy with this guy. And be careful. V cubed times v to the -3. What do you get?
V to the 0,
And v to the 0 is really
1.
1.
1. Okay. Now, if you multiply this and this together, would you agree you get 2v to the -2? And you multiply this and this together, you get v to the -3. Now, can you see why it's important that you call this particular guy 1? If you leave him as v to the 0, couldn't that lead to some complications in the next line? You need to see that that particular one is special. So here goes. The 1 gets you v. What do you get if you add 1 to this guy here?
V to the -1.
And if you divide by that new power, shouldn't I have not wrote, I should have called that negative. And this fella is going to be what? V to the -2 when you add 1. And divide by the new power, you say you get a half here. And that's going to be evaluated at these two. And I think I've done this enough, but I'm going to emphasize it as well. This is not the form that we start plugging numbers in. Don't we return to the original format? So this guy's v, this guy's going to be 2 over v, and this guy, is this guy 1 over 2v squared, or is this guy 1/2 over v squared? Or is this guy 1 over 1/2 v squared? Who is this guy?
1 over 2v squared.
Divided by v squared.
Agreed. Definitely know that one. Do you know this guy and that guy are equivalent? So I guess it wouldn't matter too much. Okay, right, back to the original problem. Since this is our last question for today, and then we'll take attendance, you go 1, take away, oh no you don't, you do 3 first. Take away 2/3, minus 3 squares, 9, minus an 18th, minus a 1, take away a 2, take away a half. And I am going to play safe and let the calculator do this. So here it goes. I'll do a bracket, just like it has here, although you probably don't need it. 3 take away 2/3, subtract 1/18. There you go. Subtract, this time I think it is important you do the subtract with a bracket. 1 take away 2 take away 1/2. Hit the math button. Number 1, 34/9.